Welcome back to Applied Algebra, Mthpt 103. We are in the exponents and roots section of Chapter 1. We have finished up the exponents section. We took a short break and we're back to do roots. So on the screen in front of you, you'll see a root. In this case, it is a cubed root. We know that because the index, or the small number here on the top, is a 3, which means it's cubed. If it's a 2, it's squared. If it's a 4, it's the fourth, and so on. The number inside is the radicand, and the symbol itself is the radical symbol. Now what this is actually asking us to do is it's saying, okay, what number times itself 3 times is 8? Well, 1 times 1 times 1 is only 1. 2 times 2 times 2 is 8. So the cubed root of 8 is actually 2. As we look down, we're going to see some other options. So here we have the square root of 25. Now I know it's a square root because there's nothing here, so it's understood to be a 2. So this question is asking what times itself is 25? Well, in reality, both of these answers are correct. 5 times 5 is 25. That's true. Negative 5 times negative 5 is also a positive 25. Those are both true. We're going to make our lives a little bit simpler, and we're going to work with just the principal root. And so if we have an even index, 2, 4, 6, positive number, we're only going to work with the positive answer. Now when you have an odd index, like 3, 5, 7, and so on, it's going to be the same sign as whatever's on the inside. Since our 27 is positive, our answer is positive. If our 27 is negative, like in the next one, then our answer will be negative. With an odd index, there's not options. It's got to be whatever the sign is on the inside, that's what the sign on the outside has to be. So we have some rules that go along with roots, just like we did for exponents. So here I have a square root of a times the square root of b. These are both square roots. Even though it's not there, it's understood to be a 2. When that happens and these are the same root, then you can put them together and multiply them on the inside. So if this was the square root of 3 times the square root of 2, that would be the same as the square root of 6. 3 times 2 is 6. That works here as well. These are also square roots. They're just understood to be that. So I can take and I can make a square root of 9 divided by the square root of 3. That's the same as the square root of 9 divided by 3, which you would go ahead and do 9 divided by 3 and give you 3. I'm missing my square root. Some more rules that we have. If we have a fraction as an exponent, what happens is the denominator becomes the index, the numerator becomes the power on the inside. So this is a to the first. It just wasn't written there because we know that the 1 is there. Last rule that we're going to talk about in this section is when I have an index the same as the power and the radicand. These are inverses of each other, and so what they do is they cancel each other out and leave us with whatever is left here. This is an a, so it's an a to the first. If it was a 2, it would be 2 to the first, and so on. So we're going to go ahead and we're going to work with these, and I have a little chart here on the side that helps. If you know your squares or your cubes, that's great, or maybe your fourths. But if you don't, then I have this little chart to help us out. You can also use a calculator if you know how to use your calculator or have one to even use. So what number 15 is asking us is there's no number here, so I know it's a 2. So it's saying what times itself is 100? Well, if you know it, then great, you can write your answer down. Now, if you don't know it, this is a 2 or a square. So squares are 2. Cubes are 3. So we're looking for an index of 2 or an index of 3. So I'm going to go down here and I say, okay, I'm going to look for the number 100. Well, there it is. So what it's telling me is that 10 times 10 is 100. Totally agree with that. So the answer to the square root of 100 is 10, because 10 times 10 is 100. Now 48, so we can try and break down 48. Is there something times itself 3 times that would give me 48? If I look down the cubes, I don't see 48. So what happens here is this is not a whole number. So I'm going to try and break it down into other options. So what we end up doing is we have to think about what goes into 48. Well, 48 is 2 and 24. 24 is 2 and 12. 12 is 2 and 6. 6 is 2 and 3. So to get 48, we can multiply 4 2's and 1 3. So 1, 2, 3, 4 2's, and a single 3. Multiply those out, I get 48. Well, I'm only looking for groups of 3 here. So I have a group of 3's. So this, what it's saying is 48 can be broken down into, so just like we can put them together, we can pull them apart. So 2 times 2 is 4 times 2 is 8. 2 times 3, which is on the outside, is 6. So the stuff I boxed went in the first one. The stuff I did not box went in the second one. Now the cubed root of 8. So I'm going to look down the cubes and I find 8. Cubed root of 8 is 2. So this changes into the number 2. There is no 6, but if I look, there's nothing that would make that happen anyway. So I leave it as the cubed root of 6. So that's as simple as that problem can go. If I look at the cubed root of 7 over 27, 7 is a prime number, so nothing's going to go there. So I can look at 27, because remember, just like I can put them together in a fraction, I can pull them apart. So I have the cubed root of 7 over the cubed root of 27. So there's nothing in the 7's, but I do see 27. The cubed root of 27 is 3. So slide a little bit. So I leave the top, it's the cubed root of 7. Cubed root of 27 is 3. So that is my final answer. Now 18 is an example where the index is the same as the power on the outside. So what happens is these are inverses, they cancel each other out. So the radical and everything disappears and I'm just left with what's on the inside, which in this case is 8/5. Those are always nice ones because you don't really have too much math to do. Okay, a few more. So if I have a fraction for an exponent, the denominator is the index, so that's a 2. The numerator is the power on the inside. Well, 16 to the first is just 16. So what this question is asking is what times itself is 16? So if you know it, great, you can go straight to your answer. You can use your calculator, or I can look up here at the squares, and I see 16, so the answer is 4. 4 times 4 is 16. And you can always check it, right? 4 times 4 in your calculator would give you 16. So now we're going to look at this one, fraction again. So we're going to go ahead and plug in, it's an index of 3. 64 goes on the inside and is to the first power, so I don't really need to do anything with that. So what times itself 3 times is 64. Go to the cube, there it is, there's 64. I slide over and it's 4. So 4 times 4 times 4 is 64. Okay, we're going to go ahead and do a story problem here. So the area of let's read the problem first. As part of her art project, Shannon will need to make a square covered in glitter. Her tube of glitter covers 13 square inches. What is the greatest side length Shannon's square can have? Well, the formula for a square is side times side, or side squared. Now the question they're giving us here is they're telling us the area, because it's covering 13 square inches. This is area. So they're giving us the A and they're asking us to solve for S. So I'm going to go down here and rewrite the equation. This is my A, so I have 13 equals S to the second. So this is saying what times itself is 13. Well, that's the same thing as doing a square root. So I'm going to change my color real quick. So there's going to do the square root. That will take that out, leaving me with S. square root of 13. Now 13 is prime, so that would be the exact answer. But I don't think that really helps very much. Shannon's not going to know how big to make her square. So let's go ahead and actually use our calculator this time. So you're going to look for the square root button. We all should have one. You just might have to look a little bit for it. Sometimes you hit the square root button first, sometimes you hit it afterward. It depends on your calculator, so check out your calculator, see which one it wants to do. My calculator, I have to hit it after I plug in the number. Square root of 13 is approximately 3.6. So Shannon can make her square just a little bit over 3.5 inches on each side. So that's the end of roots, and go ahead and work on your assignment. If you have any questions, please let me know and I'll see what I can do to help you. Have a good day. Bye.